Okay, girls, as usual, we're going to go through two exercises today, focusing on probability when you have mutually exclusive for the first exercise and non-mutually exclusive events for the second exercise. It's just a very simple definition. So mutually exclusive events is when two events can not occur at the same time. So for example, let's have a look at example 6b. It says a container holds 5 blue, 3 white, and 7 yellow marbles. If one marble is selected at random, find the probability of selecting, question 6b, a white or blue marble. So it's obviously a simple question, but the reason why that scenario is a mutually exclusive event, or where two events cannot occur at the same time, you can't pick blue or white marble at the same time because you're picking one marble at a time. That's what the question says. So that makes this question mutually exclusive. So let's just answer this question like we normally would. So if I want to know the probability of selecting a white or blue marble, that's just white plus blue marbles. So there are 3 white marbles plus 5 white marbles out of the total, which is 5 plus 3 plus 7, which is 15. So the answer to this is just basically 8 out of 15. All right. Now, this is fine, but like I said, I want you girls to be familiar with the use of the symbols. So the way I want you to answer this question is using this type of symbol. So that's what this means. Remember from last time, or is symbolized by the U or the union symbol. So in this case, because we're finding the union of white or blue, you would write W union blue. And you need to write it out separately because you know how we did it together. Obviously, it doesn't really matter how you get the answer in this question, but later on, we do need to be able to write the answers in separate fractions. So let's get used to that now instead of doing it like that. So in this question, you want to write it like this, okay? So this is a type of working out that I want you now to get used to for later chapter called discrete probability, where we need to add separate fractions. All right? Similarly, for example 6c, I'll just do it here. If it says yellow, white, or blue, you'll need to write probability of yellow, union white, union blue, and then you would have to write, obviously, the probability for yellow, white, and blue, add them up, and you get the answer. You know, you get the idea. But yeah. Okay, so I just want you to be able to use those type of symbols. All right, I'll just finish it off by writing this, plus. Example 7, the probability of winning a raffle is 1 over 350. What is the probability of not winning? There's another symbol that I want you to be familiar with. As we know, the probability of not something happening is 1 minus the probability of that event happening. The way to write the symbol for not winning, or the complementary event, is you write W for winning and you put like a bar on top to symbolize not of that. So the formal symbol for in this question would be 1 take away the probability of winning. So then you just do 1 take away 1 over 350, and then that's 349 over 350. Like I said, obviously the calculation is easy. I just want you to be able to use these type of symbols. Okay, let's have a look at example 8. Nothing really related to the stuff that we did, but just a different type of question. That's a good recap. The probability that a traffic light will turn green as a car approaches is 5 over 12. A taxi goes through 192 intersections where there are traffic lights. How many of these would be expected to turn green as a taxi approached? If we're trying to make a prediction, or if the question says expected, or to calculate the expected number of things, all you need to do is just to get that probability times by the number of things, okay? And that's basically the answer, which is 80. So we're expected to get 80 traffic lights that would turn green, all right? So probability times the number of things, or number of trials, okay? All right, now let's have a look at non-mutually exclusive events, which is the next exercise. So this is when two events cannot occur at the same time, and there's a really good example for this, which is example 9. So let's have a look. One card is selected at random from a pack of 100 cards, numbered from 1 to 100. Find the probability that the number on this card is even or less than 20. All right, so let's start this question off by writing all the numbers where this card can be even. All right, so for my even numbers, let's let's write it as set notation because we've done that from last exercise. For all the even numbers from 1 to 100, obviously I won't write them all, but it's going to be 2, 4, 6, dot, 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 all the way to 100. Okay, that's my even events, so even numbers. Now for the next part, it says less than 20. So for less than 20, actually, you know what? Let's write it like this. Less than 20 in inequality sign is just less than 20. Okay, that's just basically all the numbers from 1 to all the way to 19. All right, now here's the thing with this question. It says one card is selected at random. Find the probability that the number on this card is even or less than 20. Now, what you need to notice is there is an overlap of the even numbers here and all the less than 20 numbers here. So, okay, first of all, we know there are 50 even numbers from 1 to 100 because there are 50 even numbers and 50 odd numbers. And for this, we know there are 19 numbers less than 20. However, the problem is to calculate the probability where I'll select the card that is even or less than 20, I can't just add 50 and 19 because there are numbers here that are common in here as well. So we don't want to add those two numbers because then we're doubling up on some of those numbers. So we need to take away all the numbers that are common between these two. So let's get all the numbers where these two numbers are common to each other. So what we want is all the numbers that are even and, remember this is a symbol for and, the intersection or common. Okay, and less than 20. All right, let's get all these numbers. So what are they? We've got 2 to start off with, 2, 4. So it's basically all the even numbers up until 19, isn't it? 8, 10, 12, 14, 16, and 18. Okay, so these are all the numbers between those two. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we need to do as my final answer is do 50 plus 19, take away 9. All right, which gives me 60 numbers, okay, out of 100. So the answer is, the probability of getting that is 60 out of 100, which is 3 over 5, okay? So obviously this is how we will do the working out, but the way that I want you to be able to set this working out would be like this, okay? So this is where this bit comes in. So in my case, I'll just continue there because I'm running out of space. My PA in this case would be the 50, so 50 over 100, plus my B would be the less than 20 numbers, 19 over 100, take away the numbers that are common to each other, which is 9 over 100, and then after calculating all that, you can write 3 over 5, okay? So that's the working out that I want you to try and get into the habit of, okay? So let's have a look at example 10. All right. In year 7 at Mount Random High School, every student must do art or music. In a group of 100 students surveyed, 47 do music, 59 do art. If one student is chosen at random from year 7, find the probability that this student does blah, blah, blah. Okay, in order to do this question, you need to draw a Venn diagram, okay? Because the first thing you should notice, now what should give you an idea to tell you that it's a Venn diagram? If you do 47 plus 59, that's 106. That's more than 100 students surveyed. So as soon as you add the numbers, it's more than the number of people surveyed, that's when you know you have to draw a Venn diagram. Okay, and here's how you do it. So let's draw 2 circles and a box in case there are students that do neither. Actually, in this case, we don't have to. It says in the question, every single student has to do either music or art. So there won't be any students outside of the box that do neither music nor art. All right? So that's example 10 here. So we know we didn't have to draw a circle outside. Sorry, box outside. So the first thing you do, like I said from last lesson, is fill that number up that's common between the students that do music and art. And to get that number, it's actually what I've said. You know how I said I got 106, which is more than 100? You get that total, take away the number of students surveyed. So that's the people that does music and art. Now to get the number for, let's do music first because it mentions music first. All right. So it says 47 do music in the question. What you do is now you do 47 take away 6 to get the number of students that do strictly music only. And that's 41. So that's the number that goes in here. And the number of students that do art, it says in the question 59 do art. So you do 59 take away 6 and that's 53. And that's the number that you put in here. Okay, so this is how you set the Venn diagram up. Okay. Add the numbers up, take it away from the total number of people surveyed, and then take that number on both of the two subjects or things. So once you set this diagram up, now you can do the question. How many students does both art and music? So that will be 6 out of 100. Okay. Only art, that will be 53 out of 100, 41 for only music. Okay. I won't write them out, you get the point. All right, so girls, that's how you set Venn diagram up. What you'll notice, just one final note, 2 circles overlapping in a Venn diagram applies for all events that can occur at the same time. As you can see, it can occur at the same time. You can do music and art at the same time. When events are mutually exclusive though, where 2 events cannot occur at the same time, if you draw a Venn diagram, it's actually 2 separate circles that do not overlap. So keep that in mind. All right. Okay, girls, with that being said, you should be able to do all the 2 exercises now. Give it a go, and I'll let you know in classroom which questions to do exactly. Thanks, girls.